Afternoon, everyone. I'm Jim Cotton, mechanical engineer. My focus is on how do we decarbonize buildings. We live in a cold climate here in Canada, and we have more carbon emissions in the GTA from our buildings than we do our cars in this area. And that's because of that snow. And when I see this picture, what I see is a big, huge heat source. Everybody else sees a steel mill. That's a heat source. That heat source can heat a quarter of Hamilton. If we look at nuclear reactors, we have large nuclear reactors, as John mentioned. 15 gigawatts potential, we're doubling that in this province. There's an opportunity for heat. In this example here, we have one in the community. We have one at McMaster University. It's a research reactor. It's known for isotope productions. It's known for our research, but it's 5 megawatts of heat. That's enough to decarbonize half of this campus if we do it smartly. So it's a huge opportunity that I think when we think about nuclear, we only think about electricity, but there's far more uses as Dave and John mentioned. But you have to manage that heat. And we have a research facility here at McMaster University underneath and built into the Hatch Center for Experiential Learning, where we have our CHP, Combined Heat and Power System. In this case, it's gas. It's a little small engine. We take the heat, and then we can heat this building. In the summertime, you don't need the heat. So we store that in the ground in a thermal battery going down 7 stories. We heat up the ground to 60 degrees Celsius. So we can heat that in the summertime during peak, so we can manage our peak. So we have a demand management strategy, and then we integrate it with electric vehicles and renewable generation. This is here, and this management technology is patented by McMaster University. There's an opportunity to link that to grander thermal networks. What are thermal networks? They're district energy systems. They're pipes in the ground. In fact, there's a nuclear CHP system in Switzerland that's been operational for 50 plus years, where it delivers heat over 100 kilometers to industry, to homes, and has decarbonized the entire community. We have one in Hamilton, or in Toronto. We have a thermal network. It's called N-Wave. It's only about 26 kilometers away from the Pickering stations that John was talking about. What if we put a pipe across using our existing electrical corridors to do that? It's possible. All it is pipes in the ground. It's hot water. That's what we're shipping. We ship now natural gas to 74% of our homes. Natural gas in 30 years has been piped all over. And that is where our carbon emissions come from. 90% of our carbon emissions come from heating hot water and our homes in this province. We could do the same thing by putting pipes in the ground. We have to integrate that with storage. There's a lot of different opportunities for storage. I mentioned the one we have on campus, storing in the ground. There's pit storage. So if we have a mining operation, you can use that existing pit and use that for storage. You can use sand storage systems, which is another opportunity for high temperature storage, which we can integrate into manufacturing processes. And the one opportunity I was thinking about that you could consider is bauxite mining and alumina production. Look, we need steam. We need high temperature heat. We're doing this for another mining corporations in Saskatchewan. You could decarbonize that plant, reduce its environmental impact, and use the mining operation as your demand management. So nuclear likes to run steady state, constant all the time. Well, what if you were able to manage that by storing heat when you needed to and then using that in your plant? And guess what? There's a lot of sand because of the mining applications. Guess what? There's a pit associated with that. So you could actually start to think about ways beyond just electricity production for communities. And we're focusing right now a lot of our efforts on remote communities in Canada. There's a structural deficit in Canada, in our northern communities, in our indigenous communities, of $350 billion. A lot of that is electricity, but there's, of course, other things like food security and things like that. In Canada, we only spend $90 billion a year on infrastructure. Even if we doubled that, it would take years and years to overcome that. So what happens if we think about it and step outside of this energy poverty situation and go to energy abundance? And that's what Dave was talking about. This is the figure we're talking about here. And if, say you oversized your SMR, what would you do with it? Well, you could integrate it with your infrastructure, with your industry. You could think about other opportunities, desalination of water, using the heat. You could use hydrogen in production. All of this can be done integrated in a way that essentially levelizes the energy production, the electricity production, so that you can use the maximum benefit of that nuclear reactor. So how could you do this? You have to manage that. And that really becomes this opportunity of the ICE harvest system, which is integrated community energy and harvesting. I harvest heat, recycle heat, and reduce carbon emissions. Really, if you think about it, what we're doing is we gotta reduce and electrify, okay? But we have to electrify smartly. We have to integrate and think about thermal networks moving forward. And it could be in cold climate and hot climate. It really is, how do we do that? And finally, residual heat has value. And you know what? It's cheaper than gas. I have a company, and we harvest heat, and we displace natural gas, and we have a payback period of less than 2 years. That means waste heat is cheaper than gas. If you're interested in more information, that's our position paper. We put that together with the Boltzmann Institute and the Canadian Nuclear Association on this opportunity of integrating thermal networks, thermal batteries, and nuclear. It's a practical solution. It's a real solution. It's just not here in Canada. It's not in the Caribbean at all. But it is, and it does exist other places in the world. Thank you very much.